So welcome to day 2. Now today we'll discuss the first problem as count distinct elements in every window. So the problem says that we'll be given an array of integers and we'll be given a number k. We need to find the count of distinct elements in every window of size k in the array. So let us first of all take this sample example so that we can understand things better. So I'm quickly copying it. So basically let's say we have been given 7 elements, okay, and the elements are 1, then 2, then 1, then 3, then it is 4, then it is 2 and 3, okay. So now in this, if I give you k is equal to 4, okay, so size of every window is 4. So start like this window starting from here till here. So how many distinct elements do I have in this window? So in this window the total number of distinct element is nothing but 3, because I can see 1 is there, 2 is there, 3 is there. So 1 is repeating 2 times, basically 2 and 3. So total 3 distinct elements are there. So that's why I'll write for this, I'll write 3 elements, right? And then I'll check for the next window. So starting from here till here. So in this next window, if you will observe how many like in this next window of size 4, how many distinct elements are there? So total number of distinct element in this window is nothing but 4, right? You will see that total number of distinct element is 4 because 1, 2, 3 and 4, total 4 distinct elements are there. Then I'll consider starting from this, right? Starting from 1 till this, right? So starting from basically here till here. So basically what is the total number of distinct element? The total number of distinct element here is also 4 because I can see 1 is there, 2 is there, 3 is 4, right? So 4 distinct elements. Then the next window will be from start, like next window of size 4 will be starting from here till here. So I can see that 3 is repeating 2 times, then I have 2 and 4. So basically 3 distinct elements are there, that is nothing but 2, 3 and 4. So for this window, fourth window, what I'll say is total 3 distinct elements. So basically what I'll say is that the answer vector will be 3, 4, 4 and 3, right? This will be what I'll return as the answer, as the vector, right? Basically for every window of size k, I've tried to count it, and the first window of size k was of having 3 distinct elements, next window was having 4 elements, next window was having 4 elements, next window was having 3 elements, right? So now how can I do it? So one of the ways to do it is that what I can try to do is I keep my eye here, right? I keep my eye here and then I check for, like, let's say 0, 1, 2, 3, 4. So what I do is I every time keep like I keep eye here and then generate this particular subsequence, right? This particular like I generate this particular subarray. I keep I here and I generate this particular subarray that is having total n, like total size k. I generate this, and then what happens after, like since what will happen? I'll first of all generate this, so it will take k time to generate this, right? From starting from the ith index. Then what happens? I iterate through it once again to check what is the count of distinct element. Okay, maybe through some approach. So if there are total, like if I keeps on moving, right, every time I keeps on moving, so it will be n into k for generating all the possible windows of size k. Then I need another k because for every window I'll be checking what are the total number of distinct elements, right? So it will be n into k square kind of thing, which is a very non-optimal manner and it is a brute force manner. So instead of doing that, what I can do here is I can again use the concept of sliding window but in a smarter manner. So basically in this problem, what I can use is I can use the concept of hashing or a map. So what I'll declare is I'll have a map. Okay, I'll have a map, and in this map, what I can basically do is I'll first of all insert the first k elements. So first of all, I'll insert 1, 2, 3, and 4. So that means how many elements are there? So I'll say that map of 1 is there. Okay, so map of 1's frequency is 2. Then map of 2's frequency is what? Like 2's frequency is nothing but 1. Then map of 3 and 3's frequency is 1. Okay. So now what I'll say is I'll have an answer vector, or in that answer vector I'll insert the map dot size. Okay, what is the map size? So size of the map is what? Size of the map currently, if you see, so total number of elements. So that's nothing but 1, 2, and 3. So total 3 elements are there. So that's why I'll consider this. Then what will happen after I have done for the first part? So now is the thing. Now what will happen? I'll start my eye. Okay. So I'll say that I'll be running a loop. I'll be running a loop one by one. Okay. I'll be running a loop. So let's say my eye standing here. So I'll run a loop. My eye standing here. Now I'll check for the next window. Okay. So now eye standing here. Now what is the next? Like what is the next element? So the next element will be this, right? If you see, so 4 elements are covered. So next element will be here, right? Basically this particular window I want to cover 2, 1, 2, 1, 3, and 4. So basically I plus k will be this element. Okay. So I want to include the I plus kth element, and I want to exclude the ith element. Okay. So if I want to exclude the ith element, so whatever ith element is there, I'll decrease its frequency, right? I'll decrease the frequency. So that means I'll decrease the frequency of this element to 1, like, so its frequency changes to 1. So if it changes to 1, that means it is still existing. Okay, so you can see in this it is still existing. So if it is existing, that is perfectly fine. Now what will happen? I'll say that I'll increase the frequency of the I plus kth element. So that means I'll say that since 4 is the new element, so I'll say that the map of 4 is frequency changes to 1. Now what is the size of the map? The size of the map here, if you will see, the size of the map is 4. So that means I'll write 4 here. Okay, I'll write 4 here because in this new window you can observe that there total 4 elements are there and each of them is having frequency as 1. Then what will happen? Now what happens? My I changes. Okay, as I said, my I will increase. Okay, now what will happen? My I will come here. Okay, my I will come here. And what is the I plus kth element? This is the I plus kth element. Okay, so what I need to do, I need to exclude the ith element. I need to exclude because I am now considering this window. So I need to exclude the ith element and I need to include the I plus kth element. So if I'm excluding the ith element, right, ith element, so what will I do? If I'm excluding the ith element, so I'll say that like I'll decrease its frequency. So if its frequency is 1, so that means I'm removing. If its frequency is 1, so its frequency will change to 0. So since its frequency changes to 0, so that means it will not exist, right? It will not exist. So that's why I'll erase it from the map. Okay, I'll erase it from the map. The moment I do this, so that's perfectly fine. Now what happens? I plus kth element is 2. So I'll say that map of 2 is equal to 1, right? So since it's coincidentally I found the element 2, so I'm increasing its frequency by 1. Okay. So now again, how many distinct elements are there? That depends on the size of the map. Size of the map is 4 because 4 distinct elements are there. So now 4 again I'll write. And then what will happen? Again, if you will observe, so now my I will move again. Okay. Now my I moves again. So I moves to this one. Okay. I moves to this one. And now I plus k is this element. Okay. So what will I do? I want to exclude the ith element. So this is a 1. So now since you will see, right, since you will see the frequency of 1 is what? 1. So that means its frequency decreases by 1 because I'm leaving this element, so its frequency changes to 0. So that means I need to erase it from the map. Okay, I need to erase it from the map. So I'll erase it from the map. Okay, because I'm leaving this element and I'm including this element, right? I'm including this element because this window I'm considering. So I'm including 3. So I'll say that frequency of 3 increases by 1, so it changes to 2. Now what is the size of the map? Now you understand the importance of deleting the element which is having the frequency 1, because if map of 1 was having frequency 1, so that means I will decrease its frequency, so basically it will change to 0. So basically I need to erase it, right, because otherwise it will be counted in the size. So now you see only 3 elements are there, so basically I'll write 3 here. So that's the final answer. So that is how I have stimulated it. Now let us try and write the code for this approach. So what I will be doing here is I'll have a map like an ordered map I will be having of n comma n. Okay, and then what I will be having is I'll be running a loop. So first of all, I will be running for the first key element. So I starts from this like first of all for the first window, right? This loop will be for the first window, right? Basically, I'm iterating through the first window, right? First window, and I'll also have a vector. Okay, so maybe I can declare it later on. So basically, what I'll say is that map of a of I, right, plus plus. I'll increase the frequency of the ith element, and then what I'll say is that I need to return a vector. So I'll say that vector int answer. So basically I need an answer vector. So I'll say that answer dot push back what? Answer dot push back nothing but map dot size, right? That is nothing but the size of the map. Will tell me the number of distinct elements in the current window. And then what I need to say is that I will be starting from 0 and I is lesser than what? Now if you will notice here, so till where did my I go to? My I went till here, right? My I went till here. But suppose if my I reaches here, so do I have a I plus k here? No, I do not have a I plus k here. Okay, so that's why my I will be going till this index only, right? My I will be going till this particular index only because if my I goes here, then I do not have a I plus k for it. Okay, so this will give me a error, right? Because I'm trying to access the element I plus k which is actually not present. So that's why what I'll say is that my I needed to run till this index only, right? So that's nothing but I is lesser than n minus k, because if 7 elements are there, so how many times I am running? I is lesser than n minus k. That means I is lesser than what? 7 minus 4. So I is lesser than 3. So that means index 0, index 1 and index 2. So till this index I was running. So that's why I'll say that I is lesser than n minus k. Okay, n minus k. And then I'll do an I plus plus. Okay. So after this part is done, so what I will say is that map of if I'm including the ith element. Okay. So if I'm including the ith element, like I plus kth element, if I'm including, so I'll increase its frequency. Okay, I'll increase its frequency, and I will check since I'm excluding, right? Because I'm including this element, right? I'm including the I plus kth element, which is the new element, right? Which is the next increment to the window. So I'm including it, right? I'm including it. So that's why I'll increase its frequency. And now, what I need to say is that if the ith element that I'm leaving, if its frequency is 1, so that means its frequency will be changed to 0. So that means that means what I need to do, I need to erase this particular element, right? I need to erase this particular element, otherwise it will be counted in the size of the map. So I need to say that mp dot erase a of I, right? So I will erase the frequency of the ith element, right? This is something that I will be doing. And now once this part is done, so every time what I will be doing is I'll say that answer dot pushback, right? For this window also, I'll say that answer dot pushback nothing but mp dot size. So I'll insert the, like, I'll save the size of the map that will tell me the size of the current window, right? Okay, the number of distinct elements in the current window, and in the end I'll simply return the answer. Let us try and compile this code to see if it works on the samples. Okay, so we are getting a compilation error here. So it is saying that unordered map. Okay, so ORDERAD, right? Now let us try and compile this. Okay, so we are getting the wrong answer here. Okay, so have I done any kind of mistake? I need to check once again, right? Give me a second. So basically, if it happens that map of ith element, I'm increasing the frequency for the ith element, and then in the answer I'm pushing back the map dot size. Okay, and then for the I plus kth element, I'm increasing its frequency, right? Otherwise, yeah, I need to do with the else part, right? So what if the ith element is not having frequency is 1? So if it's having frequency 2, 3 or 4, something like that, so in that case I need to decrease its frequency, right? I need to decrease its frequency. So that is one thing that I was missing. Now let us try and compile this to see if it gives the answer of the sample. So you can see now it's working. Let's try and submit this code, because if I'm leaving the ith element and its frequency is greater than 1, so that means I'll just decrease its frequency. So you can see that our problem was able to pass all the test cases. So this is how we do it. And now talking about the time complexity, so it will be linear in nature, and since we are using extra space for map, so map extra space will be taking. Thank you for watching. Now let us discuss the problem, array pair sum divisibility problem. The problem says that we have been given an array of integers and we have been given a number k. So we need to write a function in such a way that returns true if the given array can be divided into pairs such that the sum of every pair is divisible by k. So what do we mean by that? Let's try and understand with the help of this example. So let us say that if this example has been given to us and we have been given the elements as 9, then we have been given 5, we have been given 7, we have been given 3. Okay, suppose these elements are given to us. So in that case, what we can understand is we have been given k as 6. We need to put this in terms of pair, like we need to have the pairs in such a way says that every pair, the sum of every pair is divisible by k. Okay, sum of every pair is divisible by k. So what I can try to do is here, if I see, so I can have this element 9 and 3. So if I have 9 and 3, so 9 plus 3 is 12, which is divisible by 6. Okay, so 9 plus 3 is 12, which is divisible by 6. Another pair that I can have is 5 and 7. So if I have 5 and 7, so again it will have sum as 12, which is divisible by 6. So this is the pair that I can have, right? So in that case, I'll return a true, because it is possible to divide the given array into pairs such that every pair, sum of every pair is divisible by k. Okay. Now let us try and understand with the help of another example. So let's say if we have 2, 4, 1, 2, 4, 1 and 3. Okay. Suppose we have 2, 4, 1 and 3. Suppose we have 2, then we have 4, then we have 1, and then we have 3. Okay. So in this case, if we will try to understand, so what is the k value? The k value is here nothing but what? K value I think is 4. So if the k value is given as 4, so can we divide it? Let's try and see. So maybe if we see one pair, so one of the pairs can be 1, 3. In that case, the second pair will be 2 and 6. Sorry, 2 and 4. Okay. So you will see here that this pair is having sum as 6, which is not divisible by 4. This pair is having sum divisible by 4. So in that case, I'll return a false, that okay, it's not possible. Now, what are the things that we can discuss? So basically, suppose that we have been given an array. Okay. So we have been given an array. So suppose the array that we have been given, it is of odd size. Suppose that the array is of odd size. So if it has odd size, that is odd number of elements, in that case the answer is always going to be false. Okay. Now other than this, what are the observations that we can have? So suppose we have been given the k value, suppose as 10. Okay. So what I need to observe is how do I make a pair, right? If k value is 10, so what kind of pair I'm looking for? So I'm looking for a pair whose sum is divisible by k. So what can I say? So let's say if I have a number, let's say 56, and another number, let's say I have as 24. So are these two elements making a pair such that it is divisible? Yes, it is divisible, because the sum is what? Sum of 56 and 24 is nothing but this thing, 80. Now it's divisible, right? You can see it's divisible. Now why is that divisible? Because if you will see, we can write 5 as what? We can write 5 as 5 into 10 plus 6, and this is what? This is nothing but the remainder. Okay, this is nothing but the remainder. And 24 as what? We can write 24 as nothing but this thing, that is 2 into 10 plus 4, and where 4 is the remainder, okay, 4 is the remainder. So now what are the things that we can try to observe? That if like they should exist in pair, right? Basically this, if there is a 6, if there is a 6, if there is an element with the remainder as 6, then there should be an element with the remainder as 4 as well correspondingly, right? If there are two elements, if there are two elements with the remainder as 6, then I should have two elements with the remainder as 4 as well. Okay, that is something that I need to observe. Suppose that I have like another element that I have is 66, then I should have another element, let's say 34, because these two remainders will still be the same, right? So in that case I can say that one pair maybe I can make this, another pair I can make this, right? So this is one important thing that we need to observe in this problem. So basically what is happening, if we have a particular remainder, okay, suppose that the remainder is 6, what is 4, right? We need correspondingly 4 to it. So what is 4? 4 is nothing but k minus remainder, right? If k value is 10, suppose k value suppose is 10, so 10 minus 6 will be what? 10 minus 6 will be 4. So we can use the concept of hashing here, right? It seems like basically not hashing basically, but we can store the remainders, right? And we can see like if we have a remainder 6, so like if we have a remainder 6, so suppose that what is happening, I'll have a remainder array. Okay, suppose that I keep one by one. What I do is, first of all I iterate through the elements. So int I starts from 0, I is going to be lesser than 10, and then I plus plus. So I basically iterate through the array, and what I do is I make a array, let's say v, and in that what I do is I say that let's say the elements that are there, let's say array of I modulus k plus plus. So basically I increment the number of elements with a particular remainder. What happens, let's say k value is given me to me as 4. Okay, so in that case, like, or let's say k value has been given to me as 5, suppose k value is 5. Okay, so what I need to do is I need to see like this, right? So basically this will be the element. So remainder, like if k value is 5, so the remainders will be what? If I'm doing modulo k, so the remainders will lie in the range 0 to 4. So 0, then 1, then 2, then 3, and then 4. Okay, this way they will lie. So basically what do I need to observe? I need to observe this thing, that what will happen here is you will see this part, right? So with respect to this one, I need to check it with this, right? I need to check it with this. With respect to this two, I need to check it with this, right? Because 1 plus 4 is 5 and 2 plus 3 is also 5, right? According to the remainders, right? So these will be the indexes. Now suppose like I need to check, that means I need to check for 0 independently, okay? Because 0 means what? The number is completely divisible by, the number is completely divisible, right? So if suppose that I give you k is equal to 10, okay, suppose that I give you k is equal to 10, and I give the elements as 20, and I give 30, and I give 50. So will you be able to, like, if suppose I'm telling you that at for the remainder 0 you have 3 elements, so is it a good choice for you? Like can you do it with 3 elements? No. Basically in that case what you will say is that if v of 0 is mod 2 is equal to 1, so if for the 0, if for the elements which are completely divisible by k, if their frequency if their frequency, like if those number of elements is odd, in that case I will not be able to make a pair because one element will still be left, right? So that's why I will return a false in this case. Now another thing that I need to notice is, suppose that the number of elements with the remainder as 4 is nothing but 6. Suppose that the number is 6, and suppose the number is 3. Suppose that the number is 3. So like number of elements with the remainder as 1 is 6. Number of elements with the remainder as 4 is what? Like if this is I, so this is what? K minus I. So v of I should be equal to v of k minus I always, right? Because the number of elements that are having the remainder as 6 is 6. The number of elements that are having the remainder as 1 is 6. So the number of elements that should have remainder 4 should also be 6. Only then I will be able to make the pairs one by one. Okay, so that's like, suppose that if there is 6, so and there is 9. Okay, so I need to have this pair, right? I need to have correspondingly pairs, so that means equal number of elements should be there. Okay, so here also you can observe the number of elements with the remainder 2 and remainder 3 should be the same. If this is I, this will be what? K minus I. So they should be the same. The moment they are not the same, so you'll return a false immediately. That is what we have to do in this question. Let us try and write the code for it. So what I'll be doing is I'll be having a vector int let's say v, okay, and it will be of size k because the total number of indexes will be from 0 to k minus 1. Then I'll iterate. So I'll say that for int I starts from 0, I is lesser than nums dot size, okay, I is lesser than nums dot size, and then I'll do an I plus plus, okay. And what I will be doing here is I'll say that what int, let's say remainder will be what? Remainder will be nothing but nums of I modulo k, right? Modulo k. And what I will say is that I'll say that v of the remainder plus plus. So I'll increase the frequency of the particular remainder, and then what I will say is that I need to check for the 0 condition first of all, that for the numbers which are totally divisible by k. So in that case I need to say that if it happens that v of 0 mod 2 is equal to is equal to 1. So if the number of elements which are completely divisible by k, if they are occurring in odd numbers, right, if there is odd count, if the count is odd, right, if the number of elements which are completely divisible by k, if their count is odd, then I will simply return a false, because in that case it is not possible for me to make the pair, right? Otherwise what I will be doing is, otherwise I'll start iterating from I is equal to 1, okay, till I is lesser than k, and then I'll do an I plus plus, okay, and after that I'll do an I plus plus. And what I will say here is that if it happens that now which if suppose that the remainder is I, so I'm checking for k minus I, okay. So what I will say is that if v of I is not equal to v of k minus I, okay, so in that case what I'll do is I'll simply return what, I'll simply return a false, because this will indicate that if suppose that like I is, if for the remainder I there are total 4 elements, and for the remainder k minus I, that is the corresponding remainder, if for that remainder I have 3 elements, so in that case I cannot make the pairs, right, one element will be still left, so that's why I need to return a false, because as I said, I and k minus I will be the corresponding pairs. Otherwise if I never return a false, so in the end I can return a true. That means that it is possible to make the pairs. Let's try and compile this code to see if it works on the samples. Okay, so it is giving a true answer. Let's try and submit it as well. Okay, so you can see that our solution was able to pass all the test cases. And now talking about the time complexity of this approach. So since we are iterating through this array once, right? Since we are iterating through this element array once, so the time complexity will be order of n plus order of k, you can say basically. But since k, like n will be larger, suppose, so it will be order of n, and the space complexity will be nothing but order of k, because we are using extra space, right? And let's talk about the normal problems. So like the first problem that I'm giving you as homework is zero sum subarrays. So in this problem what we have to do is, we'll be given an array of size n, and you need to find the total count of subarrays having the sum equal to 0. So you need to find the count of all the subarrays that is having the sum as 0. Another problem that is there is non-repeating character. So you will be given a string s, and you need to return the first non-repeating character in this particular given string. So you can try the brute force approach as well as the optimal approach using the hash map or something. And similarly for zero sum, you can also apply the hash map here. And now talking about the next problem. So find the missing number in the second array. So basically in this problem what will happen, you'll be given two arrays A and B, and both of them will contain n and m elements respectively, and the task is to find find the numbers which are present in the first array but not in the second array. So this is also something that you can try brute force as well as using the hash map concept as we have discussed. Thank you for watching this video.